Okay, so what I'm going to do now is I'm going to introduce how we actually generate an action potential in the rod cell. Okay, so if we remember then that this is a photoreceptor, it's going to be stimulated by light. And what I want to do is I just really want to focus on this area here. So to start with, I'm going to talk about what actually happens in the dark. Okay, so if we remember that we've just drawn our rod cell, and we're focusing on this area here, and what I would like to be thinking about really is the membrane. So with any cell membrane, okay, which we've talked about in terms of neurons, okay, I'm just going to draw basic membrane shape. And if you remember, we've got our sodium, potassium, protein pump. Just put a few more of these in, and we'll just draw a channel here. Okay, so this is a sodium channel. And then we're just going to add some labels. Okay, so literally what I'm doing is I'm just enlarging the part of the membrane here on the rod cell. And so this is my sodium potassium pump, and so we know that sodium is being pumped out. So I have 3 sodium, so it's just the same as a neuron, okay, but this is a receptor, but the same thing's happening. So sodium being pumped out, potassium is being pumped in. Okay, so generally what I'm doing is making the outside slightly more positive, which we've talked about before. Okay, but what's going to happen in the dark? So this is what's happening in the dark. Okay, so there's no light involved at the moment. That means rhodopsin is still whole. Okay, so it's the opsin and the retinol joined together. And so in the dark, sodium's being pumped out, potassium's being pumped in, but because we have actually got this sodium channel open here, these positive sodium ions are actually going to diffuse back into the cell. Okay, and so what I'm doing is I'm actually depolarizing the membrane. Okay, so the membrane in the dark is actually depolarized. Okay, and so what happens now is as we go down the cell, okay, so if you remember with the cell, okay, we're now actually making the inside more positive, okay, and as this spreads down through the cell, we're going to get to the end here where the synapse is. Calcium's going to come in, okay, and it's going to cause a neurotransmitter to be released, okay, by the synapse here, okay. Now this neurotransmitter is called glutamate, okay, and it's actually an inhibitory neurotransmitter. So what's going to happen now is this neurotransmitter is going to be released, okay, from here, and it's going to pass across the synapse, and it's going to bind to the receptors on the bipolar cell. Okay, because it's inhibitory, it's going to stop any action potential actually being passed down that bipolar cell, and so hence no signal is going to be passed to the ganglion cell either. Okay, so literally, because it's inhibitory, it's stopping any action potential being generated and passed down to the optic nerve. And so this is what continually occurs during the dark. And so we call it dark currents, because we're getting the movement of sodium passing back into the cell here. We call it dark current. Okay, dark current. Okay, so what we're going to do now then is we're going to talk about what actually happens when a photon is going to hit that rhodopsin.